Are we recording? Hope so. Hey, this is video number 2 from our section 1.1. And what this is asking us to do, I just pick another problem, number 22. So basically, I'm going through the homework and going, I'll give you an example of that. I'll give you another example and show you how to do the homework problems. And if a section's pretty thick with problems, I'll do several in that section. This particular section, the first one, just a couple of problems for you. Anyway, what this guy's doing is challenging us. It says, first of all, check to see that it is a solution. And we're talking about number 22 on page, in this case, yeah, still page 8. And here's the differential equation, and here's the possible solution. Okay, over here is the differential equation. And right here is what we call an initial condition. And you'll see what we do with that in a moment. But look at the instructions. It says, check if it's a solution. We just did that on video 1. Find the particular solution. This guy right here, okay, is a statement that says, oh, I'm going to find a unique solution given, guess what? We're going to find C given this initial condition. Okay, so let's check first to see if it is a solution. So here again is the differential equation. What we plug into that is not only y, but we also plug in y prime. So y is the natural log of x plus c, and y prime is equal to, we got to figure it out. So y prime, do you remember the derivative of natural? Of course you do. It's 1 over the inside, which is x plus c, times the derivative inside. In this case, is just 1. Okay, so what happens here is this is y and this is y prime, and we plug them into this differential equation. So here, it's weird where they go. Look where they go. The y, this guy, is plugged in for y right there, and the derivative of y is going to go right there. Okay, it's pretty exciting stuff. So we'll plug in, we'll go e, and then the power of e is y, which is natural log of x plus c, times the derivative of y, which is 1 over x plus c. And the question is that equal to 1? So we're checking, number 1, we're checking the solution. Well, it turns out, do you remember this jive? E and natural log counteract each other, and we're getting x plus c times 1 over x plus c, and indeed that's equal to 1. So it is a solution. Okay, so we did the first part, check to see. Now here's something new for our videos, is to actually find a particular solution. So take a peek at this. What we have is thus a solution family, if you will. It says y of x is equal to the natural log of x plus, you know, some sort of constant. Okay, some sort of constant you can put in there. So there's actually an infinite number of choices here. You can know natural log of x plus 1, natural log of square root of 3, whatever you want to put in there, okay, is viable, okay? And it creates a different function. In a later section, we'll talk about slope fields and how they fit and all this stuff, but it's the same thing. We're happy to find the solution. Okay, so what we'll do next is we'll use, see, the thing is, this is a family of functions swarming through whatever they're doing, but this initial condition here, this guy up here, all right, is telling you, hey, I want you to go through this point. Oh, then you want that curve, not all the others that are possible. So we find the magic value of C to make the curve go through that point. And the way we do it is we use the initial condition. It says y of 0 is 0, right? I think that's what it said. So y of 0 is 0. That means really when x is 0, comma, y also is 0. You'll find all kinds of initial conditions. X is 5, y is e, all that kind of good stuff. So, and what we do is we just plug in. So you plug in a 0 for x, and y of x is just y. You plug in 0 there, and we watch what happens. So we get equals natural log of x plus c. Okay, so we have 0 is equal to the natural log of c, right? And therefore, c is equal to e to the 0 So it has to be that C is equal to 1, or you can just tell natural log of 1 is 0. So, okay, our particular solution then, you put it all together to make your instructor happy. You just go, oh, it is y of x is equal to the natural log of x plus, and you found C to be 1. So there's your particular solution. Here's your general solution. Let's write it down. This is the general solution. And this is what we call the particular solution. Okay, so the last thing they want you to do is graph this thing. And I thought I'd just kind of slide in here a little demo on how to use Desmos as well, if you want to see me do it, that is. Okay, so let's do it. I'm going to stop the share of this. Okay, and instead we'll share, here's big face. We're going to share instead, I think, this one. Okay, so now we're on the web, okay, and I want to graph a curve. So where do I look? First, what I do is I do a search, and I did some, graph a function. That's all I did. And I cruise down, and my favorite thing is Desmos. So I'll go to Desmos. Okay, you've maybe seen it before. And I type in the curve, y equals ln of, and it says x, watch this, x, plus 1, and there's our curve. Okay, pretty cool. Now, let's say you want to cut and paste this into a Word document that you want to scan and upload to the computer for like a show your work or something like that. Well, you can take this guy and drag him over and say, there's my curve, and he's looking pretty nifty. All it is the ln function shifted over. And let's say you think that that looks good. You can enlarge it by clicking on plus maybe. Maybe you don't like that, maybe you do. Here's what I learned to do, okay? So let's say I'm gonna do the whole thing. I'm gonna go, I want to export this, okay? As soon as I do this, you guys are not gonna be able to see some of the screens, I just know. So I'll just hit this share graph, and what happens, you can see that, I'm gonna hit export image, okay? And that one you can't see, but it shows you the image, and it has a little thing that says download PNG. So I hit that guy. You might be able to see down here this. When I hit that, it's going to pop another screen you cannot see, but that is an image. And what I do on that, well, let me show you that. I'll stop the share here, and I will share that guy instead. Here he is. I'm now in Photos, okay? What I'm going to do is right-click this, and I'm going to say copy, okay? Now I'm going to stop share and go to a different share, and I think I'll go back to, where am I going to go? Here, okay? I think you're on my internet deal, and let's say I'm working on a Word file. I go here, and I go, I want a new blank document, and I right-click, and I paste. Okay, thanks for that. And it didn't work. Okay. Oh, well, it's supposed to work. I'm supposed to paste. It did work that time. Now I did a Control V, and there it is. And you can put that in your homework. I clicked on it. It's too big. So I go to the lower right corner, and I just kind of drag it up there and make it as small as I want it to be. So this is something that we do. I think we're probably going to do this quite often while we're doing differential equations. There will be a few scattered problems where I go, we want to see the graph. The homework actually says for you to graph different versions of it. So what I coulda, woulda, shoulda done was, let me go back to, wait a minute, I shouldn't have done that. Let's go back to that share. I know this video is getting kind of lengthy. Where was it? Oh, no, here. And let's say we want to go back to Desmos and say, close that. If you wanted, say, to click more guys, you can go like, oh, y is equal to natural log of x minus 5 maybe, and that's another curve and another curve. But the one we're looking for is this red one, okay? So 2 things in one here, kind of a lengthy video. The homework is doable, but I wanted to show how to do this. On another one, I'll do a slope field generator and show you how to do that one too. And I hope this has been helpful, because we're gonna stop recording. So, ciao.